This is the USA Trains GP38. It's my first USA Trains loco of this size. I have two SD70s in Southern Pacific. This is my first one for a 4-axle loco, the GP38, and it's in Rock Island, the last blue scheme that Rock Island had before they went into bankruptcy in roughly 1980, April in 1980, where they were dissolved. But at any rate, I've yet to put the rails on them, or the railings, and I'm going to put KD couplers on them. And one thing I noticed was the trucks here. They have very small wheels, and here's a wheel set that, thanks to Nick Savatke, who let me try these to replace the ones with traction tires. I'm not a traction tire fan, and this loco came with two of the axles with traction tires, so I'm going to retrofit these eventually. But notice how the diameter is here, and if you measure it out, it scales to about a 32-inch diameter tread diameter, and that really is a wheel that's probably only appropriate for a GE44 tonner loco, and certainly not for a GP38 type or a GP9 even, or an F3, F7. Similar locos that USA Trains makes. So these are very undersized wheels. And for example, I had stainless steel wheels made. Here's an example that I used in the Aristo-Craft GP40, SD45 E8s, E9s, and the Dash 9, and so on. And this is scaled to a 40-inch wheel, and you can see the relative size here compared. The wheel in the GP38 on the left here that I'm holding is very tiny. And in this particular loco, aside from the wheels, it also sits kind of low. So I measured the height to the rail head and basically looked in a book that I have that shows the Burlington Northern GP38 dimensions, and it's shy about almost roughly 2/10 of an inch to the rail head. So I think if it had bigger wheels, that would raise it up to probably close to prototypical height. But in the meantime, what I plan to do is put these spacers. I got this Lexan material, made these spacers, and I plan to remove the trucks, the motor blocks, of the truck assembly, and put these spacers, which are not quite a 1/10 of an inch, I think they're about 90 thousandths or so thick, and raise it up somewhat. And so it should be, in the meantime, till I see what to do about the wheels, it should make it a little more prototypical that way. And another thing I noticed was the air tanks here. The prototypes roughly are below the seam line here on the fuel tank, and this one's not too far off. The predecessor locos like the GP35s, and this is a GP38, and the GP7s, GP9, GP20, GP30s, they were all, the trucks were closer to the frame, and there was less of an air gap. They were typically up near where the air cylinder tank is here. Now, in contrast, this is an Aristo-Craft GP40 in the earlier Rock Island scheme, even though it's maybe a later loco, and it has the stainless steel wheels that I installed. And you can see quite a contrast here between this and the USA Trains loco here, and you see the USA Trains loco is lower, and it turns out that the GP40 here is pretty close to prototypical. Some people have said that maybe it's a 1/16 of an inch or so too much space between the truck bolster and the frame here, but that's such a small amount. And when I measured it in like-kind fashion with the GP38, I found, if anything, it might have been a few thousandths too close to the railhead overall, that is. And but it's pretty spot on, more or less, where the GP38 is a little bit too low. This is the USA Trains GP38. I have yet to put KD couplers on it or the railings. And here's a Aristo-Craft GP40. They both happen to be Rock Island. The GP38 is in the last paint livery they used before they went bankrupt around April 1980, I think, and were dissolved as a railroad. And the locos are pretty similar. The GP40 has 3 fans in the back, and the GP38 has 2 fans in the back. The 38 represents a non-turbocharged version, 2 exhaust stacks here, and the GP40 is turbocharged, 1 large exhaust stack there. And in the case of Rock Island, they didn't option for dynamic brakes, so the sides here are smooth where the dynamic brake would have gone. And as far as these models go, the Aristo-Craft one, of course, the early run GP40s were notorious for failing motors, and I put replacement motors in. The Aristo-Craft was very gracious and very nice, and apparently bought about 1,000 motors for people if they need them. So, and I replaced the motors in here, and I noticed that the GP40 with its new motors actually starts out on lower speed per given voltage. Now, the Rock Island or the USA Trains is a nice running loco, but it seems to run faster for any given track voltage. And I can demonstrate that here between the two on the same track, applying the same voltage across the track with this train engineer system here, and it's in linear mode. So I'll start this thing up, and you can see the blue engine, the USA Trains one, does go a little faster, and particularly as you increase the voltage. Now I'll go in the other direction. You'll see the GP38 catch up with the GP40. So all this means that the two are fairly incompatible to run together. And there's the Aristo-Craft GP40 road number 378 that has Aristo-Craft replacement motors in it. And these motors, I've noticed, aside from remedying the high current draw issues that was prevalent in the previous motor in this thing, it also, I noticed, the loco will start out at a speed, the wheels will start turning at a slightly lower voltage than even when the motors were working properly before, that is the previous motors. So I'm going to measure the current that the loco will draw here, and I have a setup here with an oscilloscope to basically show the voltages and currents. The bottom trace here will be the voltage. Right now it's at 0. And the top trace, or the middle trace, will represent current, and it's calibrated for the bottom trace is 5 volts per centimeter, so 1 centimeter, 1 gradation here is 5 volts, and the middle trace is going to represent current, and it's set up for add and invert 2 channels here, these first 2 channels, so that's going to be a subtraction function. And so that'll represent, that's 1 volt per centimeter gradation here, these 1 volt symbols. And so that'll represent 1 amp then, because what I've done was to put channel 1 and channel 2 across a 1 ohm sampler Dale resistor here that basically will translate voltage to current, because Ohm's law, 1 volt divided by 1 ohm is 1 amp, and that is in the line that feeds to the track here. So, and then the rollers are across the track, the ball bearing Bachmann rollers that the loco is sitting on for both ends. And this scope probe is channel 3. It's going to measure the voltage across the track. So, and that's this channel here. So I'm going to now run up the voltage, and I'm going to set it for 5 volts according to the scope here, the bottom trace. And there's 5 volts. And the current draw of the loco is It's not quite a centimeter, so it's 2, 4, 6. It's roughly about 7/10 if I average this ripple effect here, which is, I believe, the commutator causing that variation there. And so here's the loco. The wheels are turning, you can see here on the ripple rollers, both front and back trucks. So I'm going to use this as a reference to compare it with the USA Trains GP38 current draw. So again, this is set for 5 volts, and the current is roughly 7/10 of an amp, or maybe 0.75, 3/4 of an amp roughly. So here's the USA Trains brand GP38, now placed on the track rollers, Bachmann rollers, where I had a GP40 using the same rollers, and it's about identical wheelbase. And the GP38, of course, the prototype, and the GP40 were about the same lengths, and so that's nice to nice comforting to know that they're about the same. The earlier version, I should say version, but the predecessor to the 38 might have been the GP35, and that was a slightly shorter loco. But the GP38 and the GP40 appeared to have shared the same underframe. So at any rate, what I'm going to do is measure the current draw of this loco and compare it so it can be compared to the GP40, the Aristo GP40. So here's the same oscilloscope set up the same way as I did for the GP40, and now I'm going to run it up to 5 volts. That is the bottom trace here, like I did with the GP40, and we'll see what current it draws. So there's it, it's at 5 volts, and the current is slightly more. Maybe it's not quite 8/10 of an amp. It's pretty close to 8/10 of an amp, and the GP40 was 0.75 or 750 milliamps, so this is 800 milliamps. And the ripple, again, the commutator looks very comparable to the Aristo measurement. And here's the loco running on the rollers. The rollers are going around. The front truck, and there's the back truck. So it's interesting, the two brands are pretty close as far as their current consumption at least 5 volts, and yet the GP38 seems to be a physically faster loco when it's going down the track, and the GP38 also has fairly small wheels compared to the GP40. They're really under scale here. They scale out to about 32 inches, which was something common maybe on a GE 44-tonner switching loco, but not on a road loco. So if the wheels were scaled up to where they should be, the loco probably would run even faster. So apparently the gearing is the difference in the gearboxes between the GP38 and the Aristo GP40, so this is apparently geared to run at a higher speed.